Hi everyone. In this session, we are going to discuss salt. There are different types of salt. Salt is formed by the combination of acid and base, right? The reaction is known as neutralization reaction. If you didn't subscribe to our channel, please subscribe to our channel and visit our website www.winpointonlineclasses.com. Support us for providing free online classes to everyone. Let's start the discussion. Salts. A salt is formed by the combination of an acid and base. The reaction is known as neutralization reaction. In this session, we are going to discuss different types of salt and their preparation and uses of salt. Strong acid, strong base combine to form salt, right? If there is a reaction between an acid and base, there will be formation of salt. But if the acid is strong as well as the base is strong, then salt will be neutral. pH will be equal to 7, right? Strong acid, strong base equal to neutral salt. If acid is strong and base is weak, then salt will be acid because acid is strong, right? Here acid is strong, it is strong acid, so the salt will be slightly acidic. If we are taking strong base like this, it is a strong base here. Strong base is reacting with weak acid. Here acid is weak but base is strong, so salt will be basic, right? Because it is strong base. Here we are taking strong base, then it will be an salt which is having basic properties. Means here the pH will be more than 7. If it is base, pH is more than 7. If it is acid, pH is less than 7. If it is neutral, the pH value is equal to 7. Common salt. The common salt means the salt which we are using at home, like sodium chloride. We are using it at home. It is a table salt, right? How we can prepare common salt? In laboratory, common salt is prepared by the reaction between sodium hydroxide and hydrochloric acid. Sodium hydroxide is a base, hydrochloric acid is an acid. So it will be neutralization reaction. We will get common salt. NaOH plus HCl gives NaCl plus H2O. It is a reaction. NaOH plus HCl. This hydrogen and OH will combine together to form H2O, and Na and Cl will combine together to form NaCl. So here Na and Cl are combining together to form NaCl, and OH and H, they are combining together to form H2O. It is a neutralization reaction. Here this is NaCl, it is common salt. So in laboratory, common salt is prepared by the reaction between sodium hydroxide and hydrochloric acid. Common salt is formed by the reaction of sodium hydroxide with hydrochloric acid. If there is a reaction between sodium hydroxide and hydrochloric acid, we will get common salt or sodium chloride. Common salt. Industrial preparation. How we can make common salt industrially? We are using salt water. We are using sea water to make common salt industrially. Here you can see the picture. In this picture, they are making salt from the sea water. The method is evaporation. Common salt is prepared by evaporation of seawater. We are evaporating seawater, then we will get common salt. It is known as rock salt. Large deposits of salt found in different parts of the world are known as rock salt. These large crystals are often brown due to impurities. It is rock salt. It is large deposit of salt formed in different parts of the world, and the color of this rock salt is brown because of impurities. Uses of common salt. What are the uses of common salt? First one, it is used as table salt. Second one, it is used as raw materials for different chemicals. We are making different chemicals using this sodium chloride. Here there are two uses for common salt. First one is it is used as table salt. Second one is it is used as raw materials for the different chemicals. Now we can discuss that. How we can use this sodium chloride as a raw material for different chemicals. Sodium hydroxide. We are going to discuss the preparation of sodium hydroxide, and we are going to discuss the uses of sodium hydroxide. Preparation. The method is known as chlor-alkali process. Here you can see a container. There are two electrodes. These rods are known as electrodes, and it is connected to a battery here. It is a battery, right? And this one is salt solution. Salt solution is also known as brine solution. So this one is sodium chloride solution or salt solution or brine solution. When electricity is passing through this salt solution, when we are connecting it with the battery, there will be flow of electricity, right? When electricity is passing through this solution, there will be reaction, right? It is anode because it is connected to the positive terminal of the battery, It is cathode because it is connected to the negative terminal of the battery, right? During the chemical reaction, we will get hydrogen at cathode and chlorine at anode. Hydrogen at cathode and chlorine at anode. Near to cathode, we will get sodium hydroxide solution near to cathode. Here we will get sodium hydroxide solution near to cathode. This process is known as chlor-alkali process. Here we are getting alkali, sodium hydroxide. So it is known as chlor-alkali process. We are getting at cathode hydrogen, we are getting anode chlorine, and near to cathode we are getting sodium hydroxide. This reaction is known as chlor-alkali process. So can you define chlor-alkali process now? When electricity is passed through an aqueous solution of sodium chloride or brine solution, it decomposes to form sodium hydroxide. The process is called the chlor-alkali process. When electricity is passing through sodium chloride solution, at cathode we are going to get hydrogen, at anode we are going to get chlorine, near to cathode we will get sodium hydroxide. This process is known as chlor-alkali process. Next one is bleaching powder. How we can make bleaching powder? We are going to discuss that. Bleaching powder is produced by the action of chlorine on dry calcium hydroxide. We are passing chlorine through dry slaked lime, we will get calcium oxychloride. When we are passing chlorine through dry slaked lime, we will get calcium oxychloride or bleaching powder. Here you can see the reaction. Slaked lime is calcium hydroxide, CaOH twice, plus Cl2. We are getting CaOCl2, which means it is calcium oxychloride plus H2O. This reaction is the preparation for bleaching powder. This calcium oxychloride is bleaching powder. Uses of bleaching powder. First use, it is used for bleaching cotton and linen in the textile industry, for bleaching wood pulp in paper factories, and for bleaching washed clothes in laundry. There are different uses for bleaching powder: bleaching cotton and bleaching wood pulp in paper factories, for bleaching washed clothes in laundry, and it is used as a disinfectant in the water also. It is used as an oxidizing agent in many chemical industries, which will help to oxidation, that is oxidizing agent. It is used for disinfecting drinking water to make it free of germs. When we are adding this bleaching powder to water, it will kill all the microorganisms which is harmful to us, and that water will be suitable for drinking. It is also one of the use of bleaching powder. So these are the uses of bleaching powder: bleaching action, oxidizing agent, and disinfecting water, killing microorganisms, killing germs. Baking soda. Next important salt is baking soda. Baking soda we are using at home, right? It is commonly used in kitchen. In kitchen we are using baking soda in different form. We can change that baking soda to baking powder, then we can use it in the kitchen. Formula of baking soda is NaHCO3, sodium bicarbonate or sodium hydrogen carbonate. There are two names for this: sodium bicarbonate or sodium hydrogen carbonate. Now we can discuss the preparation of baking soda. Baking soda is prepared from sodium chloride. It is produced from sodium chloride. So raw material of baking soda is sodium chloride. Here you can see the reaction. It's looking lengthy, but it's very easy to learn. It's very important also. NaCl plus H2O plus CO2 plus NH3. What are the reactants here? NH3, CO2, H2O, NaCl. These are the reactants, and we are getting ammonium chloride, NH4Cl plus NaHCO3. This NaHCO3 is sodium bicarbonate or sodium hydrogen carbonate or baking soda. So this is the reaction for this preparation. You need to learn this one. You need to learn this reaction. NaCl plus H2O plus CO2 plus NH3 gives NH4Cl plus NaHCO3. This NH4Cl is ammonium chloride, and this NaHCO3 is sodium hydrogen carbonate or sodium bicarbonate. Now we are going to discuss the uses of baking soda. Why we are making this baking soda? The uses. First use, it is used for making baking powder. In kitchen we are using baking powder, right? This baking powder is made from baking soda. Without baking soda we cannot make baking powder. It is baking powder. You all are familiar with this baking powder which we are using in kitchen. Baking powder is the mixture of baking soda and an edible acid such as tartaric acid. Baking powder is the mixture of baking soda and edible acid such as tartaric acid. So which acid we are adding with baking soda to make baking powder? It is edible acid like tartaric acid. Second one, it is used as an ingredient in antacid. What is antacid? We already discussed that, right? Antacid is the medicines which we are taking for acidity. If in our stomach there is excess amount of hydrochloric acid, for digestion stomach is producing hydrochloric acid. If that amount is excess, we used to have this antacid like milk of magnesia. It will neutralize the excess amount of acid in our stomach, right? It is used as soda acid fire extinguisher. In fire extinguisher we are using this baking soda, right? So it is also one of the use of baking soda. Role of baking powder. Now we are going to discuss the role of baking powder. Why we are using this baking powder in kitchen? What is the purpose of adding baking powder? What is the role of this baking powder? We are going to discuss that. Here you can see baking powder. It is baking powder. You can see a cake also, right? It is looking very beautiful, the cake. This cake is made with the help of baking powder. When we are adding baking powder, the cake will rise up. The food items will rise up. Rise up means it will be filled of air and it will rise up. When baking powder is heated or mixed with water, just imagine we are heating baking powder or we are just mixing water into baking powder. The following reaction, this reaction is going to happen. NaHCO3 plus H plus. This H plus is from that acid. This H plus is from any acid. Usually it will be tartaric acid, and we will get carbon dioxide, water and sodium salt of that acid. If you are adding tartaric acid, it will be sodium salt of tartaric acid, right? Here from any acid, so which acid we are adding, for that acid there will be salt, sodium salt of that acid we will get. The reaction is NaHCO3 plus H plus gives CO2 plus H2O plus sodium salt of that acid. This CO2 is the agent. Carbon dioxide produced during the reaction causes bread or cake to rise, making them soft and spongy. Because of this carbon dioxide, the food item will become spongy and soft. When we are adding baking powder, it will produce carbon dioxide. This carbon dioxide will make the cake or bread spongy and soft. That is the role of baking powder in cooking. You need to learn the reaction. This reaction is very important. This reaction and this question is also very important. You need to learn this reaction. Next one is washing soda. Its formula is Na2CO3 plus 10H2O. The formula of washing soda, it is Na2CO3 dot 10H2O. That is the formula of washing soda. Now we can discuss the preparation. 2NaHCO3 gives Na2CO3 plus H2O plus CO2. We are taking the sodium bicarbonate. And we are heating that sodium bicarbonate. Here you can see it is sodium bicarbonate or sodium hydrogen carbonate. We are heating it. When we are heating this sodium bicarbonate, we are getting sodium carbonate and H2O, carbon dioxide. We are getting sodium carbonate, H2O and carbon dioxide. First step is we are heating sodium bicarbonate. We are heating sodium hydrogen carbonate to get sodium carbonate. We are taking this sodium carbonate and we are adding it with water. Sodium carbonate plus 10H2O gives Na2CO3 dot 10H2O. This Na2CO3 dot 10H2O is washing soda. So washing soda is prepared from sodium bicarbonate. First step is heating sodium bicarbonate to form sodium carbonate, and this sodium carbonate we are adding with water to give washing soda. It will give washing soda. Heating of baking soda will produce sodium carbonate. Heating of baking soda will produce sodium carbonate. 2NaHCO3 gives heat. Na2CO3 plus H2O plus CO2 in the presence of heat. Recrystallization of sodium carbonate will give washing soda. The name of process is recrystallization, and we will get washing soda. Na2CO3 plus 10H2O gives Na2CO3 dot 10H2O. That is the equation for this reaction. This process is very important. The washing soda, the preparation, and next one is uses. What are the uses of washing soda? Sodium carbonate is used in glass, soap and paper industries. It is used in the manufacture of sodium compound like Borax. Sodium carbonate can be used as a cleaning agent for domestic purposes. It is used for removing permanent hardness of water. The last use is it is used for removing permanent hardness of water. These are the uses of washing soda. Next one is water of crystallization. Water of crystallization. What is this water of crystallization? We can discuss that. There are two compounds, CuSO4.5H2O, C6H12O6. It is copper sulfate. This one is glucose. What is the difference between these two compounds? Here you can see the water, right? There are 5 H2O. Here how many H2O are there? It's very difficult to count. Not difficult, but you need to count. There are 12 hydrogen and 6 oxygen. There will be 6 H2O. It is not visible. In this compound, the presence of water is not visible. Here the presence of water is visible. This dot H2O, this 5 H2O is known as water of crystallization. It is not chemically combined with copper sulfate. It's just moisture. Here H2O has been combined with carbon. This glucose means it's combined. Chemically, water is chemically combined with this compound. So this one is not water of crystallization. Here this dot 5H2O, it is water of crystallization. It is a fixed number of water molecule present in one formula unit of salt. If we are taking one formula unit, how many water molecules are there? That number is known as water of crystallization. We can discuss some example. CuSO4.5H2O, Na2CO3.10H2O, CaSO4.2H2O. These are the compound which is having water of crystallization. CuSO4.5H2O, it is copper sulfate. The color of this copper sulfate is blue in color. When we are heating this, it will change into CuSO4 plus 5H2O. You will get 5H2O separately. Now the color is not blue. Now the color is white. So when we are heating this blue color copper sulfate with water of crystallization, after heating we will get copper sulfate which is white in color. This one is blue in color. This one is white in color. Right? So because of heating, it will lose the water of crystallization. This process is known as drying. We are going to add water back to the copper sulfate. It is white in color, right? CuSO4 white in color. We are adding water. What is going to happen? We will get CuSO4.5H2O, which is blue in color. So this unhydrated copper sulfate, which is white in color, we can use to check the presence of water. We are just adding this white powder into that place which you need to check the presence of water. Then if the color of that white copper sulfate changing into blue, we can confirm that there is water. So it is one of the agents which we can use for checking the presence of water. Now we are going to discuss plaster of Paris. Plaster of Paris is very important compound in this chapter because it is having a lot of applications in daily life. It is made from gypsum. When we are heating this gypsum at 373 Kelvin, we will get plaster of Paris. So the method is, on heating gypsum at 373 Kelvin, it loses water molecules and becomes calcium sulfate hemihydrate. On heating gypsum at 373 Kelvin, it loses water molecules and becomes calcium sulfate hemihydrate. This is called plaster of Paris. It is gypsum CaSO4.2H2O. It is gypsum. When we are heating this gypsum at 373 Kelvin, the temperature is 373. Here you can see the temperature. Here how many water of crystallization you can see? There are 2 molecules of water, right? CaSO4.2H2O. There are 2 molecules of water. So water of crystallization 2, right? And when we are heating, we will get CaSO4 half H2O. There were 2 H2O. Now it is half H2O. What is the remaining number of H2O? It is 1 by 2, right? 1.5 H2O plus 1.5 H2O, 1.5 H2O. It is a process of making plaster of Paris. We are making plaster of Paris using this reaction. Uses. Doctors are using plaster of Paris for setting fractured bonds in the right position. In the fractured bonds, for setting these fractured bonds, doctors are using plaster of Paris. Next one. It is used to make statues. To make statues, we are using this plaster of Paris. It is used to make decorative material. That is the third use of this plaster of Paris. These are the uses of plaster of Paris. If you like this video, please subscribe to our channel. Visit our website www.winpointonlineclasses.com. Support us for providing free online classes to everyone. Thanks for watching.